Hello everyone, welcome to Triaright, the new era of learning. This is Pack 365 in Module 8. Today we're going to learn about K-mean clustering in machine learning.
So nothing K-mean is nothing but it is a one of most popular widely used unsupervised machine learning algorithm for clustering. Okay, it is used for partitioning a data set into a K distinct and non-overlapping groups. Okay, uh, K-mean is we all know about the K-mean is nothing but an unsupervised machine learning algorithm which groups unlabeled data sets into a different clusters. It is used to organize data into a group based on the similarity, right? Usually, unlabeled data deals with the unsupervised algorithms mostly deals with unlabeled data, right? Here, unsupervised deals with unlabeled data to form a labeled clusters, right? By using centroids. We use clustering techniques and cluster analysis. Okay. The data analysis techniques in which the task of the grouping a set of an object in a such way object in the same group called a cluster or more. Similarly, in some specific sense, defined by the analyst to each other, then to those in other groups, it main task of EDA. We all know exploratory data analysis, EDA, and common techniques for the statistical data analysis used in many fields, including pattern recognition, image analysis, information retrievals, biometrics, and data compressions, computer graphic, and machine learning. Okay, so this is the patterns of the K-mean algorithm. Okay, like K-mean clustering, stage one, stage two, stage three, and final stage. Okay, so firstly, we want to know about the what is clustering, right? Clustering is the task of grouping similar data points together such that data points in the same group clusters are more similar to the each other, okay, than those other groups. In that, we use K-mean K-mean is a centroid-based algorithm that assigns each data point to the clusters with the nearest mean centroid. Okay, like a little bit like the KNN, but it's quite different, quite opposite, like little difference. It okay. The value K is number of clusters you want to divide into the data sets. Okay. Here we can discuss about the key points of K-means. Centroid network, the center of the point of the cluster, like average of all points in the clusters. Right? How to find a K-mean algorithm first? Here we have a data set. So we can see a data set here. So start with centroid by putting them into a random place, K2, right? Here we assign directly K2, right? I am taking the two variables, okay? Can t- we can take our wish. So first we step of the K-mean algorithm. Let us assume we want to form a K cluster, right? Initialize the K centroid randomly, randomly like this, and K random points from the data sets has a initial central point. Mostly we can say like this. Here we have a whole data set, right? From this data set, we can divide the data like this from central point. Okay, from central point, we can divide the data like this. From this to this, we mean the distance. How much distance? We created two central points. Okay, the star is red and green. So it may forms the cluster here, right? We divide the data. Now it will be separate the cluster. Assign the data points and the closest to central. Weight the central this side closest to data sets. For each data point, calculate the distance and usually k centroid. Okay, assign the points to the cluster whose centroid is nearest. We can see the centroid nearest this for red, this for green. Like that, we can see the data here. Okay, dividing the data into the center. Okay, recalculate the centroid for each cluster. Compute the new centroid by taking the mean of the point assigned the cluster. Okay, repeat the steps like this. Okay, centroid do not change. Must okay. A maximum number of iterations we reached. If it does here, like if we do this here. So if the middle point now it is little bit not a proper data set because here we can see the distance two. Here we have like wait, see we can see here we have a particular nearest data set. Here we have proper no some bit little improper data. So we can see this group, and we have a different multiple groups here, multiple group data sets in green cluster. Here we can see in red cluster we have only two data clusters. We can see the multiple clusters here. We need to divide these clusters into two types. Okay, two data sets. Okay, that's why divided line. So up to when the where the data may be divided by two, data both are divided by both sides equally. Up to we can repeat the iterations. Means we want to rotate this centroid up to the data will arrange into a proper way. Okay, we want to arrange this okay to the cluster where rotate up to the data will get properly stored. Okay, now I take another variable weight for better understanding. Oh, in iteration 2, in iteration 2, we can see the data set here, adjusting the centroid. So that comes into the become the centroid gravity. Like this, we can form the data set here. See, we can see the data here. Here we have the green data, and here we have the red data. But here little point is our start field merge. Okay, but initializing here, we can see a data set near to the red. So we want to form another divide line. Okay, another line here we can form another line, and we can repeat the cluster step again, because we can see the difference between the both lines here and here. So this time the centroid will repeat again. Now the centroid system again repeat the process like this up to the perfect data where form. Like this we can repeat the data again to here. The this angle will be repeated again. Okay, this centroid will rotate again. We can rotate this. Okay, then we form a proper structure. Okay, proper structure. We have unlabeled data like this, and we can form the how many group of clusters we have in labeled form. Okay, like we can see here, whenever the clustering moving, then we can form a final output is like this. The fourth diagram. We can see the all data divides into a proper structure. Okay, they were stored in the proper places. So mostly we use the sum of square errors like this. This formula we most use in for doing finding the k-mean. Okay, to catch the nearest data points. Okay, and in this we use elbow technique. It is a mostly we didn't assign the k-mean directly, because some maybe tell my k here I have a data set like this, because okay wait. Okay, here some maybe can say here I have a data set of I have only red and blue. I can say I have two cluster. Another one can say no, I have a three cluster. I have data one and data two and data three. And another one can say no, I have four clusters, because I have here another data, here to here another data, this to another data. I have four clusters. Like this, the clusters may be divided. So we use the elbow technique to find a proper and perfect k-mean. When the data set will be drawn a line where the elbow of the line will be matched to the point, that point will be the k. Okay. Usually we can call that point maybe k. Okay. Set a data point centered of the clay cluster, the cluster. Okay. The cased cluster. Okay. Then we can find the um, easiest path at the edge of the elbow, like bending the elbow. Here we can see the edge elbow, bending of the edge. Here where the line aligns with the data set point, we can assume it is a k point. It is a k value. Okay. For example, we can take, imagine you have a data set of a customer location. Okay, like latitude and longitude. Okay, you want to find the three customer regions where k equal to 3. We assume that k equal to 3. Randomly select the three initialized centers. Okay, like a star one, star two, star 3. We select group customer the nearest centers. Recompute the centers again. Repeat the process up to rotate the centroid. Repeat until the grouping or stable. Both data will stable. Like that, we can do the data to where the way when the data will store properly, then we get the final k value. Okay. Yeah. And here we also said choosing a right cluster is mostly used. Okay, it is a main concept in the k-mean, because we are using elbow technique. I also said that we are using elbow technique to find the best k value. because we did not always know the best value for the k to find it. Okay, run k means for various values of k, and we have the to plot k and versus sum of square errors. Okay, look for the elbow points where the SSC stops decreasing sharply. Like that, numbers will be closer. So that's the optimal number of the clusters. Okay. Here we have the most of the advantages like simple and fast, work well, and will we can spread the clusters easily. We use the large data sets in a scale. Okay. Now this we can see here, and now we can create a data like, okay, we can create a data. Depends on the data. We also know about the Iris data set, right? In previously in all models, machine learning models, we use Iris data, right? So here also we use the Iris data, Iris flower data. Okay. Again, for that I want to move to the again Jupyter. In Jupyter, create KMC, K-mean clustering. Okay. Now from K-mean, we used to firstly import the K-mean, right, from the scikit-learn. So import it first from sklearn dot clusters. I want to import K-mean, right? From here, I want to import the pandas because we want to read the data set, right? Again, I want to import the process of min-max scalar. I was to use min-max scalar, right? Again, we want to import that from scikit-learn, from pre-processing. And now we used to elbow technique, right? For that, we using graph structure based, right? So for that also, we want to import matplotlib. Import pyplot as pld, and we want the data set of Iris, right? So import it from sklearn again. We all know how to import Iris data set. So let's see how the code. Okay, we successfully installed it. Now Iris, I want to first check the data, right? If data is loaded or not. So for that, I am checking the Iris data here. That's right, it's running. Okay, the data set were loaded. Now when we check here from the not def, we can see the pt dot data frame. Load is dot data. Wait. Sorry here. Load iris, right? Iris dot data. No, it's okay. My column, and we are here loading iris, right? Want to print future names. I want to taking the future names for here. We all know this because we did this in SVM support vector machine and decision making. Most of the model machine learning models we use these sets. Okay, actually, that's why I'm directly assigning here. If you want to check it and go back and check SVM support vector machine, there we explain about in detail about the Iris data set. Now, as I'm going to say the data length, sepal length, we have sepal length, petal length, right? So from it, we want to again we want to add a flower column, right? For that we want to take the list in which you are assigning it is target, right? Target df dot add. Here we can see the flower target column here. Now we want to drop the sepal and sepal width, right? Because we don't want these values here. So let's df drop. We know how to drop the columns. Because we are dropping this to assign these values to the uh, target, right? Or we are dropping this sepal length and we are dropping again flower data set too. Here, with my PC, my lap is little bit hanging here. So right, we are assigning the columns here. So in place we want to measure the true, right? We all know in place we all measure it as true. Okay, and assign in place as true here. Sorry, equal to here we true, right? Close it, and we all okay. So done with once take a drop. We are dropping the sepal and sepal width, and we are dropping the flower axis. Okay, and now df dot head. Okay, the data will find. Now we want to create the cluster. Now we take the three clusters here. Okay, we take the cluster here three. Now we create the me. Okay, take k mean. Here I'm taking k means and n clusters equal to number of clusters equal to have three clusters three. From that YP take we are putting km dot fit for prediction here. Use predict df. Okay, from I want to print YP. Okay, I want to load the array dataset. Okay, it may be done. Okay, in final, now we want to drop the want to add the cluster, right? Cluster column. For it, we are assigning the CL cluster. yp and print df dot head here. Want to print that? Okay, fine. Now it's fine. And at the final stage, now we can proceed our easily we can do the clustering process. Okay, now it's done. And now when easily we can do cluster uniquely. Okay, for this we create a cluster dot unique cluster dot unq. Okay, right. Okay, we got 1, 2, 0. We have 0, 2, 1. We have data sets. For this, we create df1. We all know it's a support vector machine. We did like this only. From here, df dot clust or clusters equal to 0. It is one data set. Okay, we take three data sets like this. For the data set 2 and the from data frame 3 from same data set here equal to 1, which is equal to 1 comes under df2, which is equal to 2 comes under 3. Right, we created df dataset frame like this. Okay, now we want to plot it. Plt dot scattr scatter df1 to we are assigning directly three values here. So here we are giving petal length, right? Here I am assigning the petal length here. Here I am assigning petal length, and after what I want to give, let us take again df1. df1 take the line df1 some petal width, right? Doing petal width. So all data frames take petal length and petal width. That is better. No, it's okay. I take this color. I want to take the choose color, right? For color this, I can take BLU blue. Okay, so same data structure, take copy three times. So here I'm assigning 2 and here I am giving 3. Okay. Same petal length and petal width, right? Here also I'm assigning 2. Here also I'm assigning 3. And color has yellow. Here color has let be green. Okay, I'm assigning the colors here, right? Okay, now I want to plot my map. Let's wait and see what trackback error. Sorry, tuple. Where did I did mistake tuple? Okay, here we did a space here, extra over space here. Okay, right, it's fine. So now when we can see the data, how the data will define clearly. We have three clusters here. Each data after doing the rotation part, it may be divided into the different steps, the proper positions, and it will take the nearest point of the data sets, and it by using the centroid. Okay, here we can calculate the k-mean value. So here we assume our data set, and here we can calculate our k-mean, right? Easily we can calculate our k-mean here, right? So for that, now we can calculate our k-mean, like we're doing the SSC method, right? Sum of square errors, right? So take SSC as a variable and equal to a empty list. From that, I want to taking the k range equal to range. I take 1 comma 10. In that I want to take k count k in range, k range. Here take k in k range. Okay. Right. Wait. For I want to for loop here, right? Not okay. For right for k in k range. Now take the k mean here. So k means we know n clusters here also. We know n cluster equal to k here. And again k mean dot we assign the fit for df, right? We are assigning the data frame, we're dealing with data frame, so fit the data frame. It is our x and y like variables, okay? So here SSC here SSC means we also know sum of the square of errors dot I want to append the value into the SSC dot append it will be and append this km dot area. Wait, it's getting here I want to assign k equal to again. Again, okay, here I find the error here. So it is admin, we can remove no, now it works here. Okay, now it's work here. Now enter the PLT dot, there plot the X label here. And here too. Now we're doing some more. Yes, queried errors, right? Okay, K means we are at it, K RNG, right? So remove that K or okay, RENG, right? RNG here. Okay, okay, see. We can see here our elbow point is triggering to the 3. We taken perfect, we have the assume the perfect cluster here by doing a sum of square error roots by SSC method, okay, using elbow techniques, okay. Here we also say we're taking the 3 data sets. So according to the 3 data sets, we have a perfect cluster here, okay, essentially. So like we did the process, okay, by using we can like that using technical we use the perfect k-mean value, okay. Let us take a screenshot of the definitions. It will be helpful to you. Okay, I hope you guys understood and thank you.